Hello, this is Professor Choi. Welcome to one of our first classes in statistics. Today, I'm going to introduce you to basically why do you need to know statistics and what is so fun about it. Believe it or not, by the way, I'm one of those people that actually like statistics, not only because I teach it, but because I find it extremely helpful for real life. And it has helped me understand how things work and how other people make decisions based on statistical analysis. So today, we're going to have a conversation about why do you need to know statistics just like every other people, and a few other things that we need to get out of the way from our first chapter in statistics. By the way, I recommend that you also read the chapter, or at least read the PowerPoint that has a lot of definitions. So I'm trying to kind of run fairly quickly through those definitions, but if you have any questions, remember the PowerPoints are available if you're taking my class. And also, if you grab the book, all the information should be there. So I strongly recommend you at least read these particular ones on chapter 1 from the PowerPoint, because it will give you a better idea of how it works, plus it will give you really good examples. Alright, so here we go. Why do we need statistics? Well, the biggest reason is because we use it everywhere in order to make decisions. The quote that you get from your insurance company is a statistical decision. They basically look at the probability that you're going to have a crash based on all these factors. When we get to the end, by the way, of the semester in this particular class, you're going to learn how to do some of those decision-making process when I teach you something called a regression analysis, single variable regression analysis, which is not exactly what an actuarial does, but it is one way to look at how we look at different variables and we come up with a prediction for another variable. So statistics are basically used everywhere to make decisions today. They are used to make decisions on how somebody, for example, decides to give you a warranty on a particular item. In order for them to make money, they have to make a statistical decision on how much to charge you. We can apply these concepts in our life, in real life. I actually have other videos that you can watch as well. One of them, for example, is where I explain how your credit score works. And believe it or not, again, a credit score is another statistic. So basically, a particular company takes all this information from you, and then they give financial companies a number that represents how likely are you to pay back or not to pay back. And then that particular financial company can then make a decision of whether they're going to give you a loan or not. This knowledge allows you to organize, analyze, and transform data, and not only that, it allows you to be smarter about data, because it also helps you make better decisions in your life in order to put you at a better advantage for certain things. Alright, descriptive statistics. Now, there are basically two types of statistical analysis that we do. And what I mean by analysis is the way we use statistics. So basically, there are two things that we normally do with statistics. And one of them is basically we collect information and present it to people. And the second one is we use it to make particular decisions, because we make inferences about things, like inferences about a particular population. So a descriptive statistic is basically a method of organizing, summarizing, and presenting data. So it's just teaching you how to organize, summarize, and present data. And that's normally what we do in the first few chapters in our statistics class. Beyond that, what we like to do a lot is what we call inferential statistics. So inferential statistics is basically when we teach you statistics so that you can make a decision, or you can make an estimate or a prediction or some kind of generalization about the population based on a particular sample. So inferential statistics is the one that we use in order to make a decision in the future, while descriptive statistics is something that we just use to help you how present data correctly. For example, in the year 2021, the Census Department has basically come out with the latest census data, which was collected in the year 2020. In the United States, a census is done every 10 years. And census information is a really good example of descriptive statistics. So they basically collect all this information about the US population, they compile it, and they put it on all these like tables so that people can then understand it and see what's happening with the US population. That's what we call descriptive statistics. Alright? Inferential statistics is then when you take a particular piece of information that you're interested on, and then you take a sample of that, or you could be a population, and then you try to make a decision or an inference or a generalization about some product or some sale or some average or something that you want to make a decision about, or maybe if you should provide insurance for something or not. Okay? So that's what we call. Alright, now let's talk about the difference between population and sample. This is one of those questions that plenty of my students ask me and they get a little bit confused, but it's really not that difficult. A population is a collection of all the measures of interest in the data set that you have. But you can define the measures of interest. So most people, when they think about population, they think about every single one of something. But that's not really how it works, because it's kind of impossible to collect every single one of something. Instead, you want to be thinking about a collection of all the measures of interest that you have. So you can define your own population. For example, if I say, I want to collect the income, or I want to know what the average income is in the students in my class, then I have defined the students in my class as population. So in order to have a population, all I need to do is collect all the students in my class income. Alright, now what exactly is a sample? Well, a sample is a portion or part of that population. So if I define my population as all of these points are all the students in my class, for example, then a sample will be when I only take some of those students in my class. So it's when I get that group and I collect the information for some. So when I say I collected a sample of 10 students from a class of 50 students, that is a sample from a population, the population being the class. Alright? So again, that's the difference between population and sample. Another thing that we like to talk about in chapter 1 is what are the types of variables that you collect and what are the 4 levels of measurement. The 2 basic types of variables that we collect are qualitative and quantitative. A qualitative variable is a non-numeric variable, but it tells you about it tells you information that is non-numeric about a particular group. So, for example, the population, the person's gender, or the eye color of the individual, or the religion of that individual. Again, this is non-numeric qualitative data. Quantitative data is a number. So quantitative data is numeric information. Now numeric information comes in 2 flavors. One is what we call discrete, another one is what we call continuous. Discrete quantitative variable is a variable that has gaps in its values, and it's usually the result of counts. For example, if I were to count how many students are in my class, I have to go 1, 2, 3, 4, 5. Okay? Now there are gaps on that count because there is no 1.1, 1.2, 1.3, or 2.5, or 3.9. So those are gaps. So a count of my students in the class is a quantitative discrete variable. Okay, so it's quantitative because it's a number, it's discrete because there are gaps in the information, and it's a variable. Alright? Now a continuous variable is a variable that can have any values usually within a particular range. So it's continuous, but it usually starts somewhere, it ends somewhere, and then it can have a value anywhere in the middle. So you would see plenty of numbers in between 1 and 2. So it will be like, 1.1, 1.2, 1.3, 1.4, 1.5, or anything in the middle of that is also available. Okay? So a continuous variable is a variable that can assume any value within a particular range. And a discrete variable is a variable that usually has gaps in the values that it can assume. Alright, now we have 4 levels of measurement of data. And the higher the level of measurement, the more things you can basically do to it. So if you have nominal level data are observations that are qualitative in nature. They can usually be classified and counted, but the order doesn't matter. So in other words, this is a level of measurement of data where we can see it's an observation, but it's qualitative. Remember, qualitative basically means it's non-numeric. And we can classify this and we can count it, but the order itself doesn't quite matter. Like if I were to, for example, look at all the colors of people's eyes out there, so just observe how many people's what's the eye color of anybody who passes by, then I can look at that and I can classify it, but I can't really say that this is better than that or something of that sort. So this is what we call nominal level data. Ordinal level data is a data classification that has relative values. So you can say something like high, medium, or low on the data, and the data can be ranked and ordered. And notice that what we're doing here is we're sort of building up on top of. So ordinal level data is very similar to the previous example that I said, but imagine now that I assign numbers to it. So imagine that I do something like a taste test, and I give you these different things that you can taste, and I need you to give me a number from 1 to 5 of how much you like it. Alright? So taste is still a sort of something that is relative, but if I give it a value, then now I can say, well, this one tastes better, so I can say higher tasting or medium or low. Okay? So now ordinal level data is something where the relative values is what matters. Interval level data is very similar to ordinal, but with the additional property that the difference in the data values can be determined, and the difference is some number usually. Okay? So for example, temperature in Fahrenheit, the size of people's pants. Usually interval level data doesn't really have a starting point, so it could start and end anywhere. Something that's really baffling to me, by the way, it's usually why do we have small, and then after small they have extra small, and then after that they have extra small. So I can only assume that for whatever reason people have gotten skinnier over time, which by the way would be wrong, because what really happened is companies wanted people to feel like they're skinnier over time even though they're actually fatter, and they decided to move all the values down. So if you're interested, by the way, you could test this. The size of your pants, it's basically supposed to be the circumference of the area where you're gonna put your, basically where you tie your pants. And if somebody says, you're like a 32 or a 34, then you would expect that if you take a measurement, then it will be 32 or 34. But if you take that measurement, you're gonna notice that that is not true. Alright? And you're gonna be slightly surprised. So go ahead and try it out and you'll see what I mean. Alright, so anyway, that's what we call interval level data. Now, why is this interval level data? Again, because the intervals is really what matters. If I say I'm 32, 34, that's usually smaller than if I say 36, 38. Okay? So again, the interval is really what matters, but it doesn't matter where you start. So in other words, if somebody comes up with a different classification, I could be a 22, 25 on that classification. But then, of course, there'll be a higher classification of, say, 27, 29. Alright, ratio level data, it's an interval level data but with the inherent starting point. So ratio level data is sort of data that has more of all of that, and then there's a starting point that is solid. It's a point where things start for whatever reason. Begin at 0 or it doesn't have to be 0, but there is a starting point. Okay? And the difference as well as the ratios happen to be meaningful. So the difference between the information and the ratio of that information is meaningful. Alright? Examples of that is monthly income, distance travel, or most of the other things that we collect out there in order to be able to figure it out. All right. Well, this actually concludes most of the stuff that I wanted to tell you for chapter 1. I'm extremely happy that you have decided to take my class. And again, as I mentioned for chapter 1, I strongly recommend that you read the PowerPoints that I posted, especially if you're in my class, because it does a better job at explaining a lot of these, and it gives you lots of examples, which is usually what you need in order to do well on the test. All right? Thank you for tuning in to Professor Choi. Have an excellent day.